Hey guys, today we're going to be talking about AI agents. I had a whole slideshow prepared, but for beginners, it's kind of confusing if you don't see it drawn out to you first. So today I'm going to show you the concept of agents and how they actually work and why they're different from regular LLMs. So let's say we have a user that's asking us to find a flight to New York next Friday under $300, and it also says to check their calendar for conflicts. And it sends us to an LLM. Well, the LLM doesn't really have any context of what the user's talking about. Like, how does it know how to check flights? Or how does it know to check your calendar? So the LLM is going to be confused. It's going to say that I can't do this for you because I don't have access to your calendar. I don't have access to any flights because it's been trained on data in the past. So how could it know about flights that are going to happen next Friday? So this is how regular LLMs work. But agents, they have access to tools. So one tool might be able to look up flights, while the other tool is going to check the user's calendar. So now the LLM won't directly respond to the user at first. First, it'll think about the tools that it has access to. So it's going to say the user wants to check flights, so it's going to call this tool. Then it's going to say check my calendar, so then it checks the user's calendar. And of course it needs to have access to these two tools to be able to do this. And then after, it gets results back from the tool. So this tool will maybe return the flights, and this tool will return the availability of the person on that day. And this just keeps looping, it keeps on using tools until it gets all the information that it needs, or it decides that it can't continue for some reason. This is how agents work. You need tools. And now when it gets these tool results back, the LLM does all the thinking. The LLM is the brain. It does all the thinking, it takes information now, and then it returns the result back to the user. So this seems pretty simple. The LLM is the brain. It decides to use the tools if they need it or not, and then the tools return the result. The LLM uses these tool results to formulate an answer and then gives it back to the user. Let's go back to the tool calling for a second. So the LLM calls this tool, but how does it call it? Because this tool is not able to understand natural language because it's not an LLM. And the LLM can't just be like, hey, check these flights for me in natural language, because the tool can't understand this. So then the tool, the LLM says, hey, check out these flights, then the tool is going to be confused. It's going to return an error. So how do we stop this from happening? How do we actually call the tool? This is what structured outputs are for. This image over here, this is JSON. This is the JSON output. It's a way to structure your outputs, so instead of in natural language, the LLM can fill out these JSON outputs because the tool can understand these outputs. So let's say we have this key count, and we say its value is 2. So now the tool might be able to understand the count is 2 of something. Instead of saying, hey, we have 2 of these things, it's able to understand this because it can't understand natural language. But let's tune this to our example so you can actually understand what I'm talking about, because this is just some random example. This is not relevant to our use case. So instead of the LLM saying, I'm from LA and I need a flight to New York and I need it to be under $300, instead of saying it in natural language like this, it's going to send this JSON maybe. So let's say the from location is LA, the to location is New York, and the amount of money that we can spend is $300. And let's say there's more parameters, of course, but this is just an example. So it'll send it in this format. Now the tool is able to understand it because it's in a way that the tool can understand. The tool will specify that it takes in these parameters. So the tool says, you need to input this, this, and this. And this is how an LLM is able to communicate with the tool. Not through natural language, but through this JSON output here. But how does it even do that? Because it's trained to give outputs in natural language with markdown and stuff like that. Well, there are special tools out there that let you make it into JSON format. And now LLMs are advanced enough where if you just prompt it, give me this in JSON format, don't add any extra text, sometimes it's able to do it on its own like this too. So if we don't force this JSON and it adds some extra text at the start or some extra text at the end, this request will fail, which is why it's so important that JSON mode actually works, that we're able to actually structure the outputs of the LLM. But that's only with tool calls. Of course, when it's talking to the user, it will go back to natural language. And when you're orchestrating these apps, when you're building the AI agents, you're able to tell it to do this at some certain step, do it at JSON, at this certain step, it'll do it in natural language. And that's what we're going to talk about next. We're going to talk about orchestration of agents. So now you understand how AI agents work. But in a real AI agent simulation, you're not just going to make one or two tool calls like we showed in our example. In reality, we're probably making at least 10 or 20 tool calls, and this is really advanced to implement, which is why we have frameworks out here to help us when we're making our AI agents. LangChain is by far the most popular orchestration framework, and it can chain prompts together, it can add tools to your LLMs easily, it can even have memory for your agents so that you can have back and forth conversations, and it also helps you do these structured outputs that we talked about before. There's also Google's ADK, or Agent Development Kit, and it's best for if you're using Gemini already as a model. If you're not, you'd probably use LangChain, but it's built specifically for Gemini. So if you're in Google's ecosystem, it's the best way to build agents with Gemini. There's also CrewAI, and this is like multi-agent orchestration. Instead of defining one agent, you define a crew of agents, which is like one agent is a researcher, the other one is a writer, the other one is an editor, and the other one does other things. They have different roles and they have different tools. And these agents collaborate with each other. So the researcher would find some information, it would pass to the writer drafts something, and the editor reviews it. So it's like a team of agents. There's also OpenAI Agents SDK, which is OpenAI's framework, and it's kind of like Google's ADK. If you're using OpenAI, then you would use OpenAI's SDK. So there's a lot of orchestration frameworks out there, but LangChain is by far the most popular one, but it's good to explore. But here's a key takeaway to take from this lesson. Without orchestration, you just have a normal chatbot that can't do any actions. But with orchestration, you have a real AI application because you need to do some tool calls, you need to read databases, you need to search the internet. These are necessary if you want an advanced agent, because if you just made a regular chatbot, then anyone would just talk to OpenAI or Claude. What's the point of your app? Let's do a recap of what we learned so far. So agents are able to take action. That's the main thing that agents do, and what elevates them from a regular chatbot. And how does it do this? It does this with function calling or tool calling, and it uses different tools to get external information. The structured output is how the LLMs talk to these tools because they can't talk in natural language. Orchestration frameworks are what chains together these agents to make your most advanced agents instead of having to build it from scratch. So now the next video, we'll talk about how agents can talk to other tools using MCP, which is how they actually talk in natural language. I said before, you can't talk to tools in natural language. MCP changes this for you. See you in the next video.